Here we got a fun little device here from yesteryear world. HP PhotoSmart C200. If you want to know what kind of world it lives in, 1 megapixel. We're going to take it apart. Also, it has this really, also it has this very interesting little card holder. And of course it's a compact flash card. 256 meg, oh yeah, big card. Use that thing in Pocket PC probably. You didn't just see that. And yeah, interesting little lever mechanism. So not much else to say about it. Let's power it on so I can show a few funny things about like the screen and such, and get some test pictures. Uses 4 AA's, and the crazy thing has a max on here of 1.25 amps, and I'm like, oh, that's just be when it's charging up the flash. But based on the drain it's putting on all my batteries I've tried in the thing, man, it has to be like doing a lot of the stuff in here takes up a ton of current. It's just really wasting it. To think about it, we could throw it on the scope and kind of see what that current draw is over time. So I gave it some batteries, and being that's an old style, you've got the LCD on top, and being an old LCD, impossible to light. Alright, so since that's such a giant, I mean it actually is a giant compact flash card, at what style quality? Yeah, so medium quality-ish, it can take over 1,000 shots, but at super fine quality, at least I assume that's what the diamonds are, take 553, so do your math there. Full battery it claims, I don't know what the film roll means, auto flash, alright. So let's, and it takes it. And I love the sounds of the focus and everything. There, see those motors just drain it like crazy. We're already down to half battery on my, not new, but, you know, good enough batteries. While we still got some power on these. How do we get the view? Come on, I want the live view. My battery's dead? Grab the no shelf life rechargeables here. So look at that update speed. So impressive. And it does this amazing like chromatic aberration, like it can only grab certain color fields at a time or something. So if you get something moving fast enough, you'll actually see that, yeah, here we go. I'm flicking my finger back and forth. That's the update speed. All right, see that, throw it in the way. That's our update speed. Look, I can actually watch it drawing on the LCD. There you go, picture taken. We'll see what that one looks like in a second as far as its quality. Done? What are you doing? Oh, we're back to live view. That's how long it took to write the file. Now we're back to live view. Right. Standing through the lens, little viewfinder. No zoom on this except for digital. Not much else. I don't know if it has effects. I'm too lazy to try. So we'll start off our teardown by removing the compact flash card. It'll not be a teardown of that card. And start taking out screws, I guess. I keep trying to use these jewelers and then I give up because they don't work. Look how much better that is. See? I have a nice set of these things. Oh, that's a tiny screw. That's not in there at all. Oh no. Oh, I need the jeweler. Alright, that's pretty loose. Oh, that's completely loose. Ah, there we go. So apparently Konica made this thing. Oh, there's the flash cap. Short that thing out before you shock yourself, because I bet it's completely charged. A little wrist strap metal piece that went somewhere. A tripod screw piece or something. There's your cute little display. So here's my setup for sensing the current. Got our clips right on the battery terminals. Positive's going straight through, but the negative is actually going through a 1 ohm resistor with the scope probe just across it. So the scope probe and there's the scope ground. These are the connections straight through the resistor. And you measure the voltage through it as the amount of current you're drawing using some math. All right, we're on the oscilloscope measuring our current across the 1 ohm resistor. All right, so we're at 0.2 volts per division. We're going to turn it on. All right. Focusing takes a bunch. I was not very happy with that. I don't think I can go. Yep. And I just don't own batteries that have any charge in them. Turn it on again here. Right on the center, my intensity pot doesn't work, so oh well. It's kind of some cool patterns of the current being drawn there. We can actually watch it jump as it draws current for the speaker there. Slightly wider time base now. All right, let's watch the current change. We turn it on. Yep. All right, that's our draw. All right, got some new batteries. Let's see if there's any standby current. So we'll turn it on, or turn on my battery supply. Dr. Spike, don't know if there's a change. All right, so we'll turn the thing on. All right, that's pretty good. And try to try to take a picture here. All right, it's still drawing current with me just holding it. If I let go, it'll stop. But I mean, that's drawing quite a bit of current just staying there. I'll take a picture. It says my battery's dead again. Yeah, I can't. Just don't think I have enough power. Yeah, you silly thing. Yeah, this thing definitely draws a lot of power. Let's see if I can turn the monitor on here. Nope, not enough battery power. Wow, yeah, that just draws way too much current. Then again, it could also be that my dropper resistors. Let's see if it's my resistor. It's my dropper resistor. 1 ohm is just too much. Oh, come down there. Well, sadly, that just kind of shows you how much power this thing takes. My little current sense resistor combined with the resistance of the battery is just too much. If I actually was using a bench supply, that probably would work perfectly. All right, well, that was the most fun I've had looking at current in a while. We could really test this thing if I had a variable bench supply, and I could very accurately change the voltage and see where the dropout is on it. But since I do not have one of those, we will simply continue the teardown. So that's my tape holding the button in. And that's my card back. Okay. So we already went over some of what we can see. LCD on the top. Your little buttons are just the standard little things where it's just some bare contacts and you short it out with the carbon on the rubber domes wherever they are. Here we go. There's a little carbon whatever thing and point that. Shorts it out. So we're going to just take out all of these screws and see what it does. Now this little thing right here that's screwed down is actually just to maintain ground between these two boards. So that's just a little jumper essentially. Well, I bet you if I take out these two screws, we'll get the tripod mount out. Just take one of these mounting plates, see if it comes right out. There we go. Got a tripod screw. So yeah, you could just mount that into whatever project you have, and look at that, it goes right on the tripod. Okay, that made sense after I saw it. So, on this board here with the buttons is a board-to-board connector. Gotta watch out, I'm getting close to the cap. Alright, oh, okay. We are free from its housing, except for the little, oh, it's the opening switch. Oh, this is awesome. Alright, let's take a look at that. Here's the front cover. Slide it open. Click, it's on. Click, it's off. That's the feeling you're getting. Oh, I like that. Here's our camera flash cap. Oh man, yeah, I did not realize I was touching the battery contact, and I didn't know I was touching anything else either. Wow! So we're gonna not touch it now. Yeah, you can see how nasty that cap is. 100 mic at 350, I don't know what SV means. Alright, it's been a little while, let's see if there's anything in here now. There, now I'm a little better, except you gotta worry about where the wires go to, but whatever. I'll short it out when I get it out farther. Here's our speaker connector. So that is our photo flash circuit. So one of these is the transformers for it. That's probably just a choke, and that's probably the transformer, I would think. And it's the two MOSFETs to drive it or so. Maybe that one is. We'll have to get it out farther. Something's actually driving the cap going into the xenon bulb. Seems we're stuck on a ribbon cable somewhere. What we're going to do is just take out all of the screws and see what falls apart. There's the eyepiece. Here's our flash board. I think that's it. Alright, so here's all the boards. We'll kind of arbitrarily go through it. So the main board. Well, I'm trying to look at the parts of the board. I wasn't able to find many of them. So I couldn't find too much on this NEC part here, nor the Konica one here, especially not this Konica one. This is actually DRAM. It's for, I'm going to assume Megbit, or might be Megbyte. I can't tell from the datasheet too well. And this, obviously, is flash, and it's 4 Megbit. And it actually shows up as an AMD part, even though it's not AMD branded. This is some sort of digital to analog converter. Not too specific on it. It's a microcontroller, a Mitsubishi microcontroller. And these I have no idea, and the rest of it I don't have any idea. So that's it on this. Not too specific. Here's the eyepiece, nothing electronic about it. And since it's not a zoom model, it doesn't have to match the zoom, so it is not even a focus finder. It's just kind of to set up your shot. So we'll take maybe a more interesting look at the optics of it. So that button board we already looked at. Nothing too exciting. So just got some input protection stuff, some caps, board-to-board connector, and then of course our PCO element. Compact flash card thingy. So we can just slot this right in there, I'm sure. Yep, like that. Fits right in. Comes right back out. My assumption with the longer pins here would be that that's the ground pins, and they want that to make contact first. Very intelligent. Just a board-to-board interconnect there. Really popular one. So yeah, I mean, obviously since there's nothing but some resistor networks, that this is just straight pass through the processor. Side connector board with our multi-output, which I think, you know, AV connector and some other things. Your power, I think. Probably, you know, power connector or whatever to run it, since, you know, put batteries and things can die quickly. Pretty much just passives on here. It's got a fuse, 3 amp fuse. On the back, we've got a little Maxim chip, probably some sort of charge or voltage thing. I'll take a quick little chip there. Your board-to-board interconnect for the power. Nothing else too exciting. So we'll look up those models in a second. Here's our little top panel with the LCD. Little buttons. Just some boring something and others. Both the same. Yep, identical. So they're handling something obvious. Probably our display driver. Board-to-board interconnect and then a flat flex. Here's your right mounted button. And this actually has some LEDs on it. So the one on the side. The 2 for your focus and whether it can take the picture and so on. And this one for something else, obviously. I think that's our little clock or oscillator. Yep, so on our main board we've got our super cap for real-time clock and all of that. Though I don't see the obvious clock crystal, so one of the processors must be running with its own crystal and dividing it out and doing the time that way. Flat flex for the screen. Here's our actual sensor we'll look at in a second. One of the interconnects to a different board. This goes off to the flash over here. And we've got a blue filter over it. Yeah, a very limited pin device. It's only, it's 1 megapixel, so not much to it there. Pretty crazy mounting. A bunch of bypass stuff behind it, including some diodes or transistors. Don't quote me on which. Oh, this is rubber, actually. I thought this would be a plastic retention, so this is a rubber thing over it. So, we'll peel this away. Oops, well, that works. The downfall of it being rubber. Does this come off at all? Oh, yes it does. Here we go. Super cap's only 0.1 farad at, well, it's rated for 5.5 volts. So, obviously you charge the thing to 5 volts and go from there. So, yeah, that's not the longest life, but must be doing good enough just for you to get things changed or whatever. Maybe it's just designed for the 60-second change of batteries and nothing else. Here's the little LCD. Thick module since it's a pretty early one. Got 2 flat flexes for it, so probably already driven because so there might be composite video chips on there. If this is a model that runs composite, or it might all actually be digital for once, which is pretty rare in the early days. And this is our backlight driver in here. Incidentally, never try to probe one of these with your multimeter. It will cry in pain. Nice foil on our little ribbon connector. It's a really heavy model, what equates to a terrible display. Here's the lens assembly, and I already tried to have some fun making anything happen on it, and I couldn't, which was amazing. So we'll just tear it apart instead of me trying to open and close parts of it. So that comes off, and that's just a cover. And that kind of frees all of our focusingness. Look at that little worm drive here. I don't know if I can move it with my hand. Oh. Not really. After doing more work and figuring out how this actually functions, it's quite novel. So the motor goes into the side like this. And what that does is allows this piece to move back and forth, which ever so slightly raises and lowers the lens, because once you set it on here, raise it and bring it back to lower it. Ever so slightly, but just enough to focus. So yeah, once you get that motor back in there, it controls it. Pretty interesting. Here's inside the backlight driver for the LCD, and it's nothing exceptional or special. It's just a regular backlight driver with a fairly large transformer. We really don't know what else to say about the camera. Keeping the compact flash, which is cool. And it was informative and enlightening. Thanks for watching. subscribe and like and all that stuff, because I'm going to keep on making more videos. Woo! Time to clear the desk.